Today we are going to solve Cambridge level paper 5054 May-June 2022, paper 4 ATP and variant 2. Question number 1. A student determines the thickness of a glass in a test tube. The student uses a ruler and two rectangular wooden blocks to help him measure the external diameter d of the test tube. Describe with the aid of the diagram how the student determined an accurate value for d. Now we have two wooden blocks, rectangular blocks. We will place them on the table and put the test tube between them horizontally or vertically. It's up to you. You can also draw the diagram like this and your test tube will be like this. We have to find the external diameter. So now we place our ruler below them or beside them and find the values of the blocks, one over here and the one over here. By subtracting these two values, we will get the external diameter of the block. Place the test tube between the blocks. Now measure the difference of length between blocks. Your result will be diameter of test tube. Part B. The student clamp the test tube in a stand, fill the measuring cylinder to 100 centimeter cube, mark the water. Pour some water from the measuring cylinder into the test tube. The remainder of apparatus is shown in figure 11.1. The test tube containing water is also shown full size in figure 1.1. Measure the height h of the water in the full size test tube. Record h in centimeter to the nearest millimeter in the second row. With the help of scale, you are going to find the value of the h, and your value will be equal to 3.2. Your value will be 3.2 and you are going to write it in your table 1.1. Figure 1.2 shows the volume VR of the water remaining in the measuring cylinder. It is the water remaining in the measuring cylinder. Record VR in table 1.1. VR is the remaining water, so it will be 89. 89. It is the remaining water, so it will be 89. 89 centimeter cube is the remaining water inside the test tube. Calculate the volume V of the water in the test tube. Record your answer in table 1.1. Volume V in the test tube. Now we have to find the volume V in the test tube. Volume V will be equal to 11, it is 11 centimeter cube. It will be 11 centimeter cube. The volume V is the volume which have been poured out of the test tube. So it will be 11 centimeter cube. You have poured 11 centimeter cube from your measuring cylinder to your test tube. Okay, because it is total 100 centimeter cube and 11 centimeter cube is now poured into the test tube. So your answer V is 11 centimeter cube. D. The student adds more water from the measuring cylinder into the test tube. Measure and record the new values of H and V are in table 1.1. Repeat the procedure for 3 more values H and V are. The student results are shown in table 1.1. On the grid provided, plot a graph of V on y-axis against H on x-axis. So V on y-axis and H on x-axis. So V and H are already written. If we have to write them, so there will be 1 mark for it. That question will be of 4 marks. But V and H are written. The axes are written. Which one is the x-axis and which one is the y-axis? So the question will be of now 3 marks. And you have to start it from origin 0 0 and draw the best fit line. Now, first of all, what is value of V? V starts from 0 and its maximum value is 53. We start from 0 and maximum value is 53. Now marking the values for the y-axis, 0, then 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 4, 5, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 50. The gap of 10 in each block is representing 1. Now for the x-axis. X-axis we have height, and height is from 3.2 to 14.2. So now what are we going to take the difference? We are going to take the difference as every 10 block equal representing 2. Every 10 block representing 2. Let's check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, sorry, it will be 4 and it will be 2, not 10, because every 10 block is representing 2. Or 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. It will be 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it will be 40. Now we have marked our x-axis and y-axis. Now we are going to point our, now we are going to mark our points. H 3.2 V 11. 3.2 mean after 2 it will be 2.2, 2.4, 2.6, 2.8, 3 and 3.2. At 3.2 it will be 11. At 5.6 it is 21. 5.6 mean after 4, 4.2, 4.4, 4.6, 4.8, 5, 5.2, 5.4, 5.6. At 5.6 it is 21. I'm not wrong, 21. 20 and this is 21. So it will be over here. Now 8.9, 34. 8.9 will be between 8.5 and 8.4. Somewhere like here. And what is the value? 34. 30. 1, 2, 3, 4. will be over here. After that, you will have 46 and 12.5. At 12.5, you will have 46. 12.5 mean after 12, 12.2, 12.4 and 12.5. 12.5 and the value is 46. 40, 1, 2, 3, 4, 5, 6. It will be over here. After that, 14.2 and 53. 14.2, 53. 1, 2, 3, 53. The line crossing over here. It will be a cross over here. Now, as you have to draw the best fit line, you will take your scale and sorry, the points like over here or over here. Now by drawing the best fit line, you will get a line like this, which will passing through the maximum point, and upside and downside points are approximately equal. If there is 1 point upside, then there should be 1 point downside. But your line will be like this, which will be passing through 2 to 3 points. Now after that, you have to find the gradient m of the line. For the gradient m of the line, the point 1 and the point last point and the first point will be passing through the line. So I'm taking the first point and the last point. The first point is 3.2 and 11, 3.2 and 11, and the last point is 14.2 and 53. You can take any other points. Now the gradient formula y2 minus y1 over x2 minus x1, it will be equal to 53 minus 11 divided by 14.2 minus 3.2. By using calculator, you will get the value, gradient value will be equal to 3.81. Second part, if the test tube is a perfect cylinder, then the internal diameter d is given by the equation d is equal to under root 4m divided by pi. Use your value for E1 and the equation to calculate d. So d will be is equal to under root 4 times 3.81 divided by pi, and by using the calculator, d will be is equal to 2.2 centimeter. So your diameter will be 2.2 centimeter. Your value for d is approximate. State one difficulty in measuring the height of the water in the test tube and suggest how this difficulty can be overcome. So now we have to describe one difficulty and suggestion for the removal of that difficulty. We know that test tube is round. Test tube is round from bottom, due to which it is difficult to measure the height of the water inside the test tube. So how this can be overcome? Place the test tube and ruler, which you are measuring the height, on the table. By placing it on the table, you will get a better result. Suggest another reason why your calculated value for d is only approximate. So we have calculated our m for the best fit graph. M for the best fit graph. Sorry, m is calculated for the best fit graph. M is calculated for the best fit graph. That's why our value of D is also approximate. Measure the external diameter D of the full size tube in figure 1.1. Record D in centimeter to the nearest millimeter. Now from figure 1.1, you are going to calculate the value of D using a scale, and the value of D will be approximately equal to 2.4 centimeter. By using scale, you will find the value of D, which will be approximately 2.4 centimeter. So your answer will be 2.4 centimeter. Use your answer from E2 and G1. G1 is 2.4 and E2 is 2.2. E2 is 2.2. Now we have to find the thickness of the glass. First of all, we are going to subtract 2.4 minus 2.2. We will get 0.2. This is the difference between the external diameter and internal diameter. But the thickness is on the both sides. So you have to divide 0.2 divided by 2, which will be equal to 0.1. Why we have divided it? Because the external diameter and the internal diameter, both sides have thickness. Thickness is 2 times. Internal diameter D plus 2 times thickness, small d plus 2 times thickness will be equal to capital D. So for the value of, when you have to find the value of T, the thickness, D minus D divided by 2, D minus D divided by 2 is equal to thickness. So first of all, you are going to subtract these two values and then divide it by 2. Question number 2. A student investigate the cooling of a hot water in a beaker. The student measure the room temperature before starting the investigation. The room temperature is 24 degrees centigrade. The student pour 150 centimeter cube of hot water into a beaker. 150 centimeter cube of hot water into a beaker. Place a thermometer into the hot water. Wait for 30 seconds. Wait for 30 seconds. Read the initial reading of the hot water and start a stopwatch. Record the temperature theta of the hot water after every 60 seconds for 300 seconds. Okay, and this is the table he has recorded, table 2.1. Suggest why the student wait for 30 seconds before reading the initial temperature of the hot water. Because so the water mix properly. So the water mix properly and maintain the temperature. So the temperature is maintained. Why we have to wait 30 seconds? Because for 30 seconds we have to wait so the water mix properly and maintain the temperature. Because as we have added the hot water into the beaker, some of the temperature will be lost from the beaker, will be used for the increase of the temperature of the beaker. So we will wait 30 seconds so that we will get the exact result. Calculate the average value of cooling R1 for the hot water during the first 60 seconds. For the first 60 seconds, use equation R1 is equal to temperature at 0 degree minus temperature at 60 degree divided by 60. Why we have divided it by 60? Because we are calculating the temperature for each second. So we have a difference of 60 seconds in each calculation. So it will be where theta naught is the temperature of the hot water at the start, which is equal to 89.5 minus theta at 60 degree will be 83 whole divided by 60, and your result will be is equal to 0.108 degree per second. So it is a change in degree per second. Now calculate the average rate R2 for the time between t is equal to 240 and 300. 240 and 300, so 69 minus 66 divided by 60, and it will be equal to 0.05 degree per second, degree centigrade per second. Use the value you calculated in part B to describe how the rate of cooling of the hot water changes as the hot water cools. So from these two, at start the cooling rate is higher, and at the last the cooling rate is less. So the cooling rate become less, the cooling rate become less as the hot water cools. It means less heat is transferred to the surrounding. At the end of the investigation, the student leave the water in the beaker, predict the final temperature of the water after 2 hours. After 2 hours. So we can see that in only 300 seconds the temperature is now 66, and after 2 hours it will be equal to the room temperature, which will be 24 degrees centigrade. So we are going to predict that the temperature after 2 hours will be equal to room temperature, and it is 24 degrees centigrade. Suggest how the student ensure the temperature readings are as accurate as possible. So he by making sure by making sure that the thermometer is not touching the beaker. This could be the one reason. And by removing parallax error, this could be the second reason. These two reasons you can write either one. By making sure that the thermometer is not touching the beaker, because if it is touching the beaker then your temperature will be not accurate. And by removing the parallax error, by your eyes parallel to the thermometer. Part 3. Three students A, B and C measure the speed of sound in air. Student A and B stand at opposite end of the football pitch. Student A strikes two large blocks of wood together. Student B starts a stopwatch when she sees the block hit each together, and stop the stopwatch when she hears the sound. The student repeats this procedure twice. Student C measure the distance d between the student A and B. The time records are shown: 0.45, 0.41 and 0.51 seconds. Calculate the average value of t. Give your answer to two significant figures. For the average value, we are going to add 0.45 plus 0.41 plus 0.51 and divide it by 3, because we have three values, and it will be equal to 0.46. Your answer is 0.4567. By converting it into two significant figures, it will be equal to 0.46. Now the distance d between student A and B is 119 meter. Suggest a device that can measure the distance. So we know that for the measurement of distance greater than 119 meter will be measuring tape. Now we have to calculate the value of v, velocity, and velocity is equal to distance over time. So distance will be 119 divided by time will be 0.46, and your answer will be equal to 258.6 or you can write it at 259 meter per second. Suggest why one reason why the value calculated in B2 for the speed of sound in air is only approximate. As we know that the speed of sound in air is 333 meter per second. But as we have calculated here is 259. So what are the errors? What are the possible errors? We have taken the average value of t. Average value of t. One error. Second, human reaction time for start and stop of start and stop of stopwatch. Because we know that human reaction time could be wrong for the start and stop of the stopwatch. Human reaction time for start and stop of stopwatch is also a reason for the approximation in the calculation. A student investigates how the resistance of a filament bulb changes when the current through it is varied. The student connects the circuit shown in figure 4.1. The student has connected the circuit incorrectly. We can see that ammeter is always connected in series and voltmeter is connected right, but we are going to discuss it for the filament lamp, so it should be placed across the filament bulb, not the variable resistor. In the space below, redraw the circuit with the voltmeter and ammeter connected in the correct position. So we will have a battery. With the battery we have a variable resistor. With the variable resistor we have the bulb, and after bulb we are going to attach our ammeter and voltmeter across the bulb, so we can calculate the voltage across our bulb. When the switch is closed in the corrected circuit, the student observed that the lamp does not appear to light. The filament of the lamp is not broken and the battery is not run down. What observation does the student make to confirm quickly that the filament of the lamp is not broken? So it is right here, the filament of the lamp is not broken. It means that current will pass through it. And if the current will pass through it, your ammeter will going to show some reading. So we can write it like ammeter will show some reading because current will be passing through it. Current will be passing through the bulb. So ammeter will show some reading. Suggest why lamp does not appear to light. Why? There could be two reasons. The voltage across the uh, bulb is low, or the current passing through the bulb will be low. The current passing from the bulb is small. If the current passing through the bulb is small, then there will be no light from the bulb. Or you can also write is the voltage across bulb is small. What could be the reason for the voltage across the bulb is small? Our variable resistor has a very high resistance, due to which more voltage is dropped across the our variable resistor, due to which there will be less voltage across the bulb. The bulb will not going to be glow.